All right, we did standard deviation last time. And the standard deviation is based on the normal distribution. That's what we had with the empirical rule. If you go 2 standard deviations up and 2 standard deviations down, that's 95%. That's the bet. 95% of the population will be in there. If you go 1 standard deviation up and 1 down, the bet is 68%. Right? And those are bets. We get a number and that comes up. We're going to do a different version of it's not the empirical rule, it's relative position. And we're going to need in Excel, or in MyOpenMath, this file. Empirical rule and box plots, 40 observations. And there it is. And I'm going to enable editing. And we're going to use this. We're not going to do it right at the moment, but one thing we need to do, and this is why it's important that you're using Windows. I don't know how a different version of Excel works, but we want to change or turn off automatic calculation. Right now, if you change a number, if you've got that file open, if you change a number or you hit enter or something like that, it will recalculate. We don't want it to recalculate until we tell it to. So go to File, up on that far left. Go to File, up on the top left, and you get this menu. And depending on your screen resolution, you see more or fewer items. On this one, we have to go to More, which is the last item. And if you have a different screen resolution, you'll see it in the bottom. This is Options. We're going to click on Options. And this is where you set all the defaults for Excel on your computer. And go to Formulas. In Formulas, the very first item is Workbook Calculation. And we want manual calculation. I don't know whether the file that I put on there has it already set. So look at manual calculation. If it isn't marked or highlighted, go ahead and highlight it. Because in this, we want to do there's z-scores, so on. We want to do percentiles, deciles, and quartiles. In parametric statistics, they assume that the normal distribution is at the bottom of everything, whether it is or not. And all the bets are based on that. In this, we have nothing but order. Instead of the numbers being important themselves, it's what order they are in. So that if we have a list of numbers, one of the things that we have that we've already done is the median. The mean, median, and mode. The median is in the middle. It is literally what number is in the middle. So I've got 1, 2, and 3. 2 is in the middle. If I have 1, 2, and 100, 2 is still in the middle. It's the median. So that this is called resistant, because if I calculated the average for 1, 2, and 3, I get 2. If I calculate the average for 1, 2, and 100, I get 30 something. So the average just goes screaming off when you get a big number. or get a really small number. These are skewed like this. This one represented looks more like this, where the average is way over here and the median is down at the bottom. So the median is a good thing, and the problem with the median is we didn't have computers. The guys who invented statistics didn't have a computer. If they had, we would have used the median as much as we used the mean. We literally couldn't calculate it, because if we had a list of 100 numbers, we would have to sort all of them and then find the number in the middle. Couldn't do it. Have you ever tried to sort numbers? Get the smallest, then get the next smallest, then find the one that you just missed, and then you had to go back and start again. But now, we just put it in a computer and say, sort it. So, all of these things are as useful as what we have for mean, standard deviation, and so forth, and we simply couldn't do it. So the median is what's in the 50% position. Purely what number is in the middle in a sorted list. I don't care how big the numbers are, how small, I have them sorted, and I go to the middle number. So if I have 40 observations, I want the number in the middle. The number in the middle, there's going to be 20 smaller and 20 larger, so that I would have to average the 20th and the 21st observations. Right? It isn't even a number that's in the list, but it's in the middle. If I had 39 numbers, I would want the 20th, because then there's 19 smaller and 19 larger. This is a calculation that purely depends on sorted order. It's called an order statistic. What I have to go with the median are percentiles, deciles, and quartiles. And the percentile is just what position in the list is a number as a percent. Like the median's at the 50%. Well, I can have a number at the 7th percent. I can have a number at the 93rd percent. And this is the way they do SAT scores. They just sort them and they give you a percentage. Here's your percent. There were this many below, there were this many above. In this, I have percentiles, which is 1 to 100, 0 to 100. The deciles are 10% steps. 10% here, 20% there, so on and so forth. Deciles aren't used as much. Mostly it's percentiles and quartiles. Quartiles are the main ones because there's not so many of them. There are 4 quartiles. This is the first. It's everything less than the 25th percent position. The second quartile is between 25 and 50. The third is 50 to 75. And the fourth is 75 to 100. And all we're doing is finding where these things are. And here's the kick. Even with the median, there are 15 different ways, at least, that I know of, to find the median. You would think the median's in the middle, no big deal. Well, you would be wrong. Everybody's got some weird idea because it suits their particular setup. the ones that are most common or the easiest to use are just a formula that says, I've got n observations, I want the p percentile, like 50 percentile. If I have 40 observations, I multiply that by 0.5 and I get 20. Because I got 20, I average what's in the 20th and the 21st position. Right? And there's examples here of how to do these things. The easy way is to use the quartile commands in Excel. And that's what we're going to do with these other things. This is the n+1 method. Right? You add 1 to the sample size. If you want the median, you multiply that times 50%, 0.5. So for 40 observations, I multiply 41 times 0.5, and that gives me 20, what's in the middle? The 20.5 position. That says you're in the 20.5, take the number above and the number below and average them, which is what the 20th and the 21st is, half above, half below. For 25%, I would do 0.25 times that number. If I get a fraction, I take the average of above and below. If I get a whole number, that's the one, whatever is in that position. And literally, if you have a version of Excel on a Mac, you will get a different answer than someone who's using Excel on a PC. If you use Google Sheets, you will get a different answer than you would from Excel. They're all the same if you've got enough numbers. If you've got 1,000 numbers, there's going to be no difference. This is simply 40 numbers. And these are generated from a random number generator. One of them has no skew. It is all the numbers like a normal distribution, except they're randomly distributed. So this is the bell-shaped curve. And if you look at this no skew column, we have 40 observations. And down here, this is what it looks like. If I do a histogram for this, the bar chart. If I recalculate, I will get a different set. And to recalculate, you do Shift F9. Because these are randomly selected from the distribution, I'm not guaranteed to get a perfect bell-shaped curve. Here is my bell-shaped curve in this instance, but it may not be perfectly bell-shaped. If I have a skewed distribution, this is skew right. Remember, skew goes with the tail. Skew right means tail right. And if you look at the distribution, it has a lot on the low end and then it tails off on the right side. This one is skew left, and it has a low beginning, then comes up here. This is the most common kind of distribution. Most things, like house prices, have a skewed right distribution because some houses cost basically what a house cost, and then you get Bill Gates' house. So you get a number way out on the end, and it pulls the distribution this way. So I got a long tail to the right. When I do this, the median is back here compared to the average. The average is pulled this way by the high number at the end. It goes the opposite for the skew left, and there's not many good examples for this. The two that are there are light bulbs and lifespan. You ever put in a new light bulb, you turn it on, it blows out immediately? But mostly, it just sits there. So that a light bulb has a very long lifespan, relatively speaking. Very few of them blow out quickly, but more blow out when they get older. So it's left skewed. Lifespan is like this. If you manage to be born and live for the first 6 weeks, you are pretty much guaranteed to live for 30, 40 years, minimum. And as you go, you start to lose people. So you get to 70, 80 years old, more people die. They just don't live that long. There's always somebody that's out here. But the circumstances of people just make that right or left skewed distribution, which is very rare, in fact. Most things, we treat them as though they are symmetric, and they look like this. All right, we have a sheet here, and we're going to make what's called a box plot. And this is based on what's called the 5-number summary. The 5-number summary is the minimum. We have a sorted list. The minimum is the number at the bottom. The maximum is the number at the top. And the median is in the middle. And this is called a box plot. One reason it's called a box plot is because it looks like a box. With this, we can mark the median and the quartiles, and this is not a bet. 25% of the numbers we have are between here and there, 0 and the first quartile. 25% are between the second or the first quartile and the second quartile, which is also the median. 25% are between the median and the third quartile, and 25% are above the third quartile up to the maximum. We're going to make box plots using these numbers. Right? You've got a number, and everybody's got different numbers here probably, if you've recalculated. So look at the numbers in the no skew column. In this, we're going to do some calculation here, and I'm going to take the first 20 values, just because we don't need all of them. I'm going to take the first 20 values, mark those, then go up to Home and Copy. Go over to the side, anywhere, and we want to paste and paste values. And that literally takes what is there and moves it over. If you don't do that, and there's a calculation in the original cells, it will try and move that calculation as well. So we've just got numbers there. Go to Sort and Filter up on the top. And there's a lot of ways to sort things. Basically, we want to sort these numbers smallest to largest. So if you pick smallest to largest, there they are. I have 20 values. If I use the NP thing, I got 20 of them, I'm going to have to average the 10th and the 11th to get the first, or the median. For the first quartile, This is the 25% position. I want 20 times 1/4, which is 5. In this calculation, I find the 5th and the 6th. I want the numbers in the 5th and the 6th position. I don't care what numbers they are. I just want them in that order. So I go back and look. And here's another trick. Go to the side, the column in front of it, and put a 1. I got a 1 in that column. Then I'm going to mark that entire list all the way down, just blocked off, and then at the top, depending on your screen resolution again, you have a fill command. If you have a smaller screen, it's going to say fill. Otherwise, we have to go to this spot and say fill. I'm going to click on fill. And I want to fill with a series. I'm going to click series, and it says, what kind of fill do you want? And I want the step value to be 1. And I want it to be in columns because I already got it marked. I tell it OK. And it gives me a list from 1 to 20. And this is purely a convenience now. I can find the 5th and the 6th to get the first quartile. So here's 5 and 6 on mine, which 5 is 32, 6 is 33, so that the first quartile is 32 and a half. On your sheet, pick a column or a list, find 32 and a half, and mark that spot. And for a box plot, the first quartile, you put a line. Zero, 10, 20, 30, 40, 50, 60, 70, 80. My first quartile is at 32 and a half, somewhere here. And I put a line. So find 32 and a half on the line and make a vertical line. The median is the one in the middle. So that for this, my median is the 10th and the 11th, which is 35 and 36 for me, and I average those and I get 35.5. I go back to the picture, 35.5. My median is 35.5, which is right here. Hopefully yours is a little bit separated. The 75th percentile, the third quartile, is, well, the other one was between 5 and 6. This one is going to be between 15 and 16. I have 40 and 41, so mine is 40.5. 40.5. And there I've made the central box. This is the first quartile, the median, the second quartile, that's the third quartile. The minimum is 29 and the maximum is 47. So 29 and 47. But the 5-number summary is the minimum, first quartile, second quartile, which is the median, the third quartile, and the maximum. Pick a spot over here on these 20 that I got and do equals. And start to type QU, and I get quartile.exe, quartile.inc, and a couple of other things. Quartile.exe and .inc will give me different answers because exe means it won't use the median when it finds the first quartile. INC means it does use the median when it finds the first quartile. If that makes no sense, that's because it's silly. But that's the way it is. So we have to decide on one or the other. I usually use the INC. Let's use the INC. Double click. The first thing we need is the array. Mark the numbers that we have, then comma, and it gives you a list of things that it will do. If you put in a 0, it will give you the minimum, 1, first quartile, second or 2, median value, 50%, 3, third quartile, or 4, maximum. Now we can find what we want. Let's just do the first quartile. So we'll put a 1 in there, close that, and see what we get. I said my first quartile was 32.5. This one calculates it as 32.75. If I go to the next spot, I'm going to calculate it with the dot. What did I use here? INC. I'm going to calculate with the dot EXC. QUAR brings up quartile, and I want EXC. Array, comma, 1, first quartile, and I get 32.25. Literally, these are supposed to be the same thing. And there's another 13 ways to calculate these things depending on what you're doing. All you have to do is stick with one. I usually use the .inc because it matches most with what I need to do. If there's enough numbers, it will always be the same or close enough that it doesn't matter. But even here with 20 observations, I got a difference between the .inc and the .exe. And there's no right answer in this. It depends on who you're talking to and what they want to do. That's the quartile commands. And I can get the second quartile, which is the median, or I can use the median command. It will give me the same thing. And then the third quartile. And I just change the 1, 2, and 3 at the end of this quartile command. Here it's quartile.inc. The data, and 1, that means first quartile. These numbers are a frequency distribution, and if you click on there, you can see it's a frequency distribution. This is what generates that graph, that bar chart, that histogram. And it shows that this is no skew. If you go up and look at what's calculated there, the minimum is the quartile.inc, and the data's got a name here, and 0. That's minimum. The next one is the first quartile, second quartile, which is the median, third, and the fourth. Pick a spot and make a box plot for whatever data you've got. Take the sheet. You want to go and mark the minimum with a dot. And here I've got 28. I've got 28, which is about here. That's the minimum. The next quartile, the first quartile, is 32 on mine. So I put a line at 32. The median is 36. I put a line at 36. The third quartile is at 40.25. 40.25. I make a box there, put a line, and the maximum is at 49. Put another dot. This is sometimes called a box and whiskers plot, where the first quartile to the third quartile is a box, and then the minimum and the maximum are whiskers at the ends. Right. Not only is there different ways to calculate the quartiles, there are different ways to use the box plot, mostly in terms of what's the minimum and what's the maximum. This one was a no skew. Here's skewed right. Go to your skewed right calculation. And for this one, the minimum is 20. The maximum is 42. Minimum is 20. Maximum is 42. And 25, 29, 25, 29, 32.25. Look at the way it came out on your sheet. It doesn't have a wide spread, but look at it compared to the no skew. It's moved that way. You can detect the skew looking at the box plot and the 5-number summary. Right. And again, before, with the standard deviation, we had bets. 68% between here and there, 95% between up to, down to. This is a fact. There are 25% of the observations in each one of these pieces. Instead of making bets, I've got a fact. And it depends on whether you want to deal in fact or bets. And there are sometimes when you want to deal in bets, and sometimes when you don't. Look at the right skewed. Minimum 29, mine 39, 41, and 42. This one is pushed to the right. It's more over here. So that it has the tail to the left, which means skew left. That's how these are done. What they are used for. If you go back to My Open Math, there's box plot pictures. And this is a box plot, fancy one, right? And the distance between the first quartile and the third quartile is called the interquartile range, the IQR. Right? More important than how you calculate these things is what is it. When somebody shows you this, you have an idea of what's going on. So here, the interquartile range is from 55.5 to 33. That's a guarantee that 50% of the observations are between those two ends. You can compare this to the +1 standard deviation, -1 standard deviation, where we have a 68% bet. This, between the first and the third quartile, is a 50% fact. This is the way that box plots are used for comparison. And this shows cholesterol distribution by weight class. Underweight people are at the bottom, overweight and normal at the top. And what they're looking for is, do these distributions overlap? Look at the underweight people. How far up does their cholesterol go? What is the maximum, particularly compared to the interquartile range? You go to the overweight, look what happens to the tail. And in this particular one, the observations at the far end are the maximum and the minimum, and these in here are, they're called outliers. But you can see there's a lot of more information out there. So that these things are outside of the ranges that we got. The number, or that little square, or diamond, is the average. So here's the average, and the median is the line. And that's what the box plots look like, and that's what they're used for. And it's quite common to see these things. You can make box plots in Excel. And you don't do anything except tell it to make a box plot. And it's interesting, it's kind of limited, but it will show you the maximum, the minimum, the median, first quartile, third quartile, and the average, the mean. And you can get an idea of what these things look like. So these things are the way that evaluations are made. Do these things overlap, like these cholesterol? Is there a real difference between the bulk of the people in these weight classes? How much overlap is there in the interquartile range? The median here is enclosed in that, and it's enclosed in that. It's only the first quartiles, in this case, and the second quartile, or third quartile in the case of overweight, that are outside. But there is no test for this. You have to look at this and decide for yourself. Are these different? Do they need different treatment? In this case, who needs treatment? It's not entirely obvious, but it's pretty clear. It's the overweight. You don't need to worry about the underweight people or the normal people. It's the overweight people that have bad cholesterol. But now, do they have bad cholesterol because they're overweight? Or are they overweight because they have bad cholesterol? That's the other thing statistics can't deal with. What's the cause? That's the 5-number summary and box plots. And it's an alternative to the standard deviation and the bets. That's purely a matter of which way you want to approach these things. And it doesn't matter. There are perfectly valid arguments on both sides.